So first of all, I guess I should start by apologizing for GWT, the word GWT. When we thought of the name, we said, GWT is a nice acronym. Somebody pointed out people will probably call it GWT eventually. And I said, no, that'll never happen over my dead body. And then a year later, I'm calling it GWT. And I can't stop. So sorry about that. We just have to accept it and move on. But that's okay, because GWT is really not about being cool or fancy. It is actually about getting work done. Now, there is a ton of surface area in GWT. And so you know, it can fill multiple days worth of very technical sessions. We can only hit the very high level stuff here. And then there's a wide variety of people in the audience. Some have used GWT heavily. Some are actually really almost brand new to GWT. So some of this stuff you may have seen before. And if you were here yesterday, I did actually 3.5 hours of nothing but GWT slides. And I touched most of the surface area, but even in 3.5 hours, only very superficially. So there's a lot of stuff we both want to say and different points we want to make. And so what we thought is we'll just present together. Maybe we step on each other's toes. We'll just huddle around the little slide advancer keyboard button here. And then basically we're just going to tag team this. So we're software guys. We're not professional speakers. But hopefully you will see the point of productivity gains with GWT. So let's tag team this baby. Come on. Okay.
You should probably hit that.
I hit next.
Right. So I want to take a step back and make sure everybody's on the same page about what GWT is all about. The whole point is that we want to let developers build Ajax apps that users love. And really what that means is that the way we've chosen to do that has two side effects that are great for you as developers. One is that you get to build Ajax apps that work for all the different browsers because your users come sort of in Firefox and IE and Safari and all that kind of things. You don't have to worry about the cross-browser quirks. The second one is you get to leverage the Java development tools that you already know and love, as we were all just talking about with Josh. So to take a step back, if you want, we wanted to talk about the GWT mission statement. So when we went open source about a year ago, we came up with this, which is a little bit of a mouthful, but I thought that I would emphasize a couple points. But actually, you can sum this up by channeling Larry Page and just saying, focus on the user and all else will follow. The whole point is we were trying to make the web better for users, and at the same time, let developers make that easier. So looking now at what is in GWT, we sort of talked about some of the goals. At the very core, there's the Java to JavaScript compiler, which, again, does cross-compiling for all the different browsers out there. We have the hosted mode debugger, which the whole point there is that we wanted to let developers do debugging in their own code. It doesn't make sense to try and debug the output of JavaScript, and so that's where the hosted mode debugger has the fast refresh cycle, so you're able to do that quick iterations. The JRE emulation libraries to be able to leverage all of the sort of java.util and other libraries that are out there in so much that they make sense for the web. The widget library is a very important piece to it to make sure you don't have to build your own buttons, and sort of some of the very basic pieces are there, so you can just leverage them and CSS style them however you want. And we have a lot of other libraries, RPC, XML, JSON, those kind of things. But I'll let Bruce kick it off with a little demo now.
Yeah, sure. It makes the most sense, really, to take a look at the code and see how it works. So this is the simplest GWT application that you can typically write. You instantiate a button widget, you set up an event listener, and the root panel really represents the body of the HTML page, and you can insert widgets into the entire body if you want to. You can also insert them into just sections for integration cases, but in this case, we're just inserting it into the body itself. Even though this looks like Java code that you would write, say, in Swing or something, the point of GWT is that this is actually going to become client-side Ajax code. To show you how this looks in Eclipse. That was my plan anyway. Oh yeah. I'm a switcher, so I still have to learn all the fancy Macisms. All right, can you guys see that okay? All right, so this is Eclipse. There's no particular plugin or anything. This is just plain vanilla Eclipse. I run the launch config for hosted mode. Dan talked about the hosted mode debugger. What hosted mode means is that you're working in your favorite Java tool, your IDE, and you can actually bring up this browser here, which is actually a real browser, but it's tied into the JVM through low-level JNI hooks. You don't have to ever deal with that, but what's important to realize is that when you run your Java code, it's actually taking little bits of JavaScript behind the scenes at the leaf methods, shoving them into this hosted browser, and then binding the behaviors between your Java code and the JavaScript code. It sounds really technical, but the benefit of that is your code really behaves the same way in the browser, even when you're working in Java. It wouldn't be good to like build a Swing app and then hope it kind of worked identically in the browser. You actually want to debug against the real browser, so events behave like you'd expect and so on. So anyway, the upshot of all that is that I am running in the VM right now inside my IDE, and the Java code actually runs. It becomes particularly clear when you set a breakpoint. So now I am debugging Ajax code that is written in Java using a Java debugger that isn't even specially tailored towards GWT. So we thought that was kind of cool. And we found some additional points of integration with the debugger. So debuggers in Java tend to call the toString method on objects in the variable watch window here. We took advantage of that to show you the HTML that is rendered by that widget. And so when I select the sender object here, which is the button that actually sent this click event, you can see here that you're getting the HTML associated with that button. So for a button, this is pretty simple, obviously, but for a complex widget, it can be really useful, and you start to gain a deep understanding of how widget architectures kind of map onto the corresponding DOM structures. So then, I guess the cycle is complete when you click this little button, the compile browse button, and in the background, the GWT compiler runs. You get an equivalent application that is pure JavaScript. It works the same way. In this case, this is Safari, but that same compiled code will work in Firefox and Opera and Internet Explorer and Safari and even various mobile WebKit versions.
And then you just grab that code and throw it in your web server and you're done.
Absolutely, right. That's an important point. When the GWT compiler finishes, there's no more server-side dependencies at all. You can optionally use an RPC component with GWT, but the point is that it's really just static JavaScript files. You can serve them up out of a vanilla Apache instance, or even some people serve directly out of source control, which is kind of cool. Anyway, so.
Yeah, question. That window, is that a Java object, and then that it generates a window object for the time?
So let's hold the, especially if it's really technical, let's wait until the end and get into that. It's easy to go nuts really quickly. So productivity matters, right? Especially productivity as time goes on. But here is how most organizations actually end up becoming Ajax shops. So if you've heard me talk before, you've definitely heard this pitch, but it also really resonates, and it might be happening within your company right now, so it's worth repeating. Okay, product manager comes in, somebody like this guy, and says, you know, we need some Web 2.0 features in our app. You've been happily a Strut shop, and you can, you know, produce Web 1.0 applications on schedule, under budget, and everything, but you're like, okay, well, it'll be fun to learn JavaScript, and so you add a little feature here and there, and people really love it. So why wouldn't we want to do more of this? So product managers go out and make promises about features.
Salespeople.
Thank you, Dan. Salespeople go and sign up for things that you haven't even designed or have no idea remotely how to build. And before you know it, you're an Ajax shop, not a Java shop. And by the way, you've been trained in Java, but you've never been trained in Ajax. In fact, nobody's really been trained in Ajax. You pretty much just keep the browser quirks, the quirksmode.org web page up and constantly refer to that. Then the salespeople come back to you after making these grand promises and say, well, now we want to sell into a company that won't run on Internet Explorer because of security concerns. They want to run Firefox. And that is when things get really messy because you've only really written JavaScript for Internet Explorer before. So now you're going to try to support Firefox, and you find it is a huge uphill battle. So the inevitable result is that you start to have a certain disdain for the experience of writing JavaScript. It's not that JavaScript per se is bad. It's just that the practical reality of all these browsers is that each browser did its best to implement things in a way that seemed to make sense. It's just that they all did it differently, and there's widely different behaviors, compatibility issues. There is also a standard, although it's not actually useful to program against it in many cases. So you learn to hate browsers with sort of deep, burning hatred that you can only do once you've tried to port like really complex Ajax code across them. And then, of course, you fail, because that's what happens. And users hate it even more, absolutely. But naturally, of course, at this point, you quit because who could expect you to maintain this spaghetti code? You're an Ajax guru now. You slap that on your resume, go get your next job, and make more money.
I'd really like working with Bruce, but I guess not so much anymore.
Anyway, the point is, you're going to be writing Ajax code in the next 2 years, almost certainly. Even if you don't think you are, your users will tell you that you are. But it's really easy to end up accidentally making a big investment in Ajax, and the question is it a good investment or a bad investment? At the end of all this work that you do, are you going to have a code base that you're glad to own? So we sort of look at GWT as a way to bring software engineering practices to the world of Ajax. It's really important that you use tools that you already know. So GWT works with any IDE. It's not a specific plugin for one IDE. We wanted to make sure there's a rapid edit, debug, test, give it to users to make changes. That sort of cycle needs to be really rapid. Java IDEs do that well, and we don't do anything to prevent that from working. We wanted to make sure you can do all the good unit testing that you're used to doing with JUnit, so there's deep JUnit integration. We wanted to make sure you can reuse sensibly, not the way that it's done in the sort of handwritten JavaScript world, which is, I think they call that copy and paste reuse. You reuse it through jars like you would expect. That's the way that it works well in Java. You want to be able to take advantage of things like design patterns. If you're familiar with the Gang of Four design patterns book, there's some great stuff in there. Some of those patterns, you have to have a strongly typed language like Java in order to do. Visitor springs to mind as one that is really useful, but you can't do it in JavaScript because you don't have overloading on function types, on function parameters, I should say. Little things like documentation. Some developers choose to document their code, and we encourage that. That was a joke, sorry. But we do actually encourage it, but it was supposed to be funny, I guess is the point. So just having JavaDoc as a standard, having tools around JavaDoc, it's really nice to be able to write your code in Java. And then, of course, compile time errors, which the guys just beforehand were kind of going into that in a lot of depth. And you get all those benefits automatically just from the GWT approach. Aside from productivity, you're just not writing bugs in the first place.
So since we're all geeks, we thought we'd go ahead and take a look at what productivity means from a sort of math perspective. And when you're thinking about it, you have functionality, which, just to be clear, this is functions that users need, not just things that you happen to be able to implement. So the important point there is that just random whizzy technology is not interesting to users. It actually gets in their way, right? And so the point is the amount of functionality you're able to deliver that users want times the amount of reliability, because a function is only so good insofar as that it's actually reliable and users are able to have it do what they want it to do. And the point about time to deliver being on the denominator is because time's really always working against you, especially when I'm working on a project with you, because I'll be wanting to get it, ship it the day before, as Bruce can speak to. So that's really sort of where the math comes in.
Last night we tried to vet this equation against a couple guys on the GWT team, and we just meant it to be sort of fluffy, hand-wavy, and quasi-technical. And then Joel said, well, it does actually make sense as long as you clamp the range of values from 0 to 1.0. And then Kelly pointed out that this would seem to imply that you can add a ton of features even if your reliability is low and you still get good productivity. And those things are true mathematically, but please don't get bogged down. In fact, Joel suggested a much better way to explain it. Like a three-legged table. You have to be able to deliver quickly. You have to build the right set of functionality. And that functionality has to actually work when it gets into the hands of your users.
We actually have a three-legged table on the stage with us.
And we have a three-legged, right. And if I were to, hypothetically, kick over one of the legs, the table would fall. So that's a pretty decent analogy for what productivity really is. It's not just about banging out code. It's about banging out the right code that actually works when you're done.
So now we want to jump into sort of each one of those pieces of the equation. So functionality, as we've been talking about now, we're going to harp on this a lot. So I'll apologize now. Just usability is so important to actually having apps that users can deal with.
But it's a fair point to harp on because unless you really start with that goal in mind when you're designing a JavaScript library or anything for building Ajax codes, there's a tendency to want to write the spinning button control and not some other control that directly relates to something a user will care about. So it's the right functionality. Yeah.
So having random animations versus having some feature like autosave in your web email is, there's a pretty obvious trade-off there in terms of which is going to be more functional and usable for the user. So I wanted to step through some examples of what we've seen as we've been browsing around the web. We call this one here the don't use your back button feature. It turns out that a given website out there will make it so that you can't actually use the Chrome around your browser such that it's designed. It doesn't really make a whole lot of sense.
And users are trained to use their back button, right? And this is like a 12-step wizard that's an application for a mortgage. So like if you make you remember you made a mistake on the previous page, you click back because that's what you do on every other web app. All of a sudden you're in this no man's land and you're not sure, maybe your computer's broken permanently.
With the right tools, you can actually fix this with Ajax apps.
Right.
Then we have another favorite, the accidentally pay us twice feature. So the real question about this one is what happens when your network hangs? What is the user supposed to do? They click submit, and then they get the little error where it's like, hey, your wireless network dropped. Do I click again? I don't know. I mean, it's silly that the actually client-side web app shouldn't be able to know that the payment's in process.
Right, and both of these really are kind of tied back to the Web 1.0 architecture where there's the act of doing something means a full page refresh. And so really, Ajax can solve both of these because as you decouple updating the UI from interacting with the server, once those two things are disjoint, then you have the option to update like in response to an error instead of just showing like an ugly, HTTP 500 error, which is not good. It'd be much better to pop up a dialog box.
Yeah. Or just update the UI itself. Like.
Mm-hmm.
So
Is your phone going?
Maybe.
I'm hearing some phonage.
So this one is even better. Can you count the number of ways in which they're just like targeting a tiny, tiny, tiny set of the users out there? IE6, 800 by 600 with Java enabled. And then they recommend yet another browser and call out some other browser. It's just like way too much to throw at the user.
We can sell to anybody as long as they're exactly this person.
All two of them.
So that really brings up the point. Features can only be defined in terms of their value to users. Who are these users that we're talking about? Well, it turns out there are a wide variety of users when you take an application to the web. I mean, I'm sure you've all seen these points made before, but it's nice to hear them all in rapid succession so that it scrambles your mind, and then you'll start to realize some things about productivity with GWT.
Scrambles your mind in a good way, so you sort of understand the full scope, not in the bad way.
Well, it is kind of scary. I mean, language, grammar, right to left. Some people like to read their text right to left because that's how they kind of like learn how to read and stuff. Character sets that have fonts that look totally foreign to you are very familiar because that's the language that another user might use. Even things like choice of icons and colors and symbols, different cultures have very different norms, and then you can kind of do it wrong if you use the wrong, say, color to represent an error message. Red doesn't always mean bad. Then there's other things you might not see day to day, interaction aids like input method editors. So if you have a lot more characters than you have characters on the keyboard, you need like extra software devices to help you enter these extra characters. So you have to consider, will the Ajax code that I'm writing be able to sort of work with those IMEs? Then you've got assistive devices like screen readers that are really important. And so you have to be thinking about being able to be accessible to people with a wide variety of sort of different capabilities and strengths, and additional tools like assistive devices. You've got people using all sorts of hardware and different operating systems. Mobile makes this even more complex. Even RAM and CPU speed. Just when desktop applications are like pretty fast and like even your mom has 2 gigabytes of RAM, mobile devices come along and they have totally different set of constraints. Mobile devices need to use the least amount of power possible, so they want to use the minimum amount of RAM, and they want to use the minimum amount of the slowest CPU that you can possibly get away with.
For battery power.
For battery power. And then, of course, mobile devices are small. And there's more. You've got different network characteristics. So like, for example, dial-up is just kind of slow all around. But satellite networks have weird characteristics, like very long latency, but actually really good bandwidth. So something like an IM sort of or a chatty application will work really horribly over a satellite network, whereas big downloads work really well. So to try to kind of account for all the different environments in which your app will be used is hard. Then you've got widely varying skill levels of users. So maybe one-size-fits-all application isn't right. What the power user wants and what the novice user wants may be completely different UIs. So you have to kind of think about features relative to what that user wants. And then, of course, everybody has their own browser choice, right? Everybody has their own special browser they want to use, and it would be a real shame to build Ajax code for your vital application for your company, and then the user can't use it in the browser of their choice.
I just have to underscore dial-up, because I think that we as geeks always forget the fact that there are just so many users out there that don't have broadband. And I don't know what the number is, and I probably should have tried to research it beforehand, but the basic point is that there's a lot of users out there in the US and also outside of the US that are still using dial-up or otherwise slow connections.
Okay, so now, how does GWT help on the fronts of functionality? So one thing we did that's sort of unusual is that we really emphasized functionality like internationalization really early on. Sorry, that was supposed to be Safari. So this is the sample that ships with GWT. You do this little trick so that you can make sure you have your character encoding right. Because if you don't, it'll look funny.
It's like the quick brown fox, kind of.
Right. Not that it doesn't look sort of funny. But, so with one of the first things you have to do is format numbers and date times for different locales. So there are a lot of different locales, I think, in GWT right now. Shinjin, are you in here? I think we've got, about 400? 400 right now? Yeah. So that's tough. That's tough.
You can touch a lot of users with.
Right. Yeah. Absolutely. And it's something that, as a developer, we give you like a simple API for date, time, and number formatting and parsing, and you just write it, and then it automatically gets adapted to all the different locales that you want to support. So you can play with this application later. It's in the distribution, but
and it's live on the website.
And it's live on the website. But there's a wide variety of functionality. Most importantly, though, it is all happening client-side. So it's really complex logic that would be extremely hard to implement in JavaScript, even harder to implement efficiently by hand in JavaScript. And it's something that was vitally important to us. So you don't have to do HTTP round trips just to format and parse numbers in multiple locales. That would hurt the user experience, and yet it is absolutely vital to serving your users. So what was the other? History and bookmarking. History and bookmarking is another great example of how you can get this wrong really easily. I read an article one time that said about Ajax in a magazine. It said, the first thing you have to understand about Web 2.0 is you can't use the back button anymore, which is horrible. I mean, that's one of the things that made the web so popular in the first place. It's really simple, hyperlinks that you can email around, back and forward, and bookmarks. These are really good usability things because they're simple and they work well. You can't sacrifice that when you go to Ajax. So we spent a lot of time working on this relatively unsexy aspect of the problem, history support, making back and forward and bookmarking work well. So in this example, which is called Kitchen Sink, it just shows sort of a high-level view of the various widgets. I should show pop-ups as well.
We should show a couple of cool ones.
Yeah. This is
Scott.
Scott Bloom is our compiler tech lead.
Who's that guy?
That would be Jimmy Carter. I don't know why he's brandishing a lightsaber at the former president, but
in the next frame, the Secret Service actually tackled Scott.
Not really. But anyway, so as I was clicking through there, I was actually accumulating history state, which is kind of cool. Then you do things like, let's say you go to
totally different app.
Totally different
web
app.
page, really. App web page, users shouldn't have to care.
Absolutely. And notice I back into my Ajax app, which did have to reload from scratch, but by clever use of the history mechanism, I'm able to retain the history stack. So you can go back and forward through other completely foreign pages, and your application can be written such that it still works correctly. And that is the ideal. The ideal for usability is the app seems just like any other web page, just like way faster, way better, way more functional. The other little neat thing that I always like to show is the ability to just bookmark things. We call it constant bookmarkability, so that whatever state you're in, you can just say bookmark this state, and it will work. That's actually really tricky to make it happen. But as you can see, I was able to just easily create bookmark into that state. And then the RPC is the last one. Now, I probably should have ordered these differently because this is like the least sexy looking one.
Should have been in the middle.
But this is actually running live off of real production servers, so it's sort of what the website really is in practice in terms of speed. And this uses GWT RPC in the background. And so, we count milliseconds with everything that we build. And so this is the kind of like direct, fast feedback that you really want when you're using an application. If you, let's say you're a customer service person and you're using a web app to like pull up a user account or something, you've got to go through a lot of data quickly. The difference between this and click, wait. I'm sorry, sir, my computer's running slow. I hope you understand. Just one more moment, please. I'm sorry, how did you spell your name again? You can see how it can really make a difference.
So that covers the functionality part pretty well. To step back to the equation, functionality times reliability divided by time to deliver.
Notice there was no animation or special effects in any of the stuff that you saw just now.
Indeed. So reliability, obviously a crashy application doesn't actually help the users. If the features just crash when the user's trying to use it, that's not going to do anything good. The inconsistent performance, I'd actually say, is worse, though. When you think about it, if I have a feature that works most of the time, but it's really slow sometimes, it's actually going to mislead the user into thinking that it's going to work, and then it's really slow, and you'll get something like this. What does that mean? I mean, as to the user, why do browsers show that to users? It's just mean. And really, why do developers? It is.
Absolutely.
And why did developers not use GWT? No, never mind.
More parents have bought new PCs because they got error messages like this, just to find out that really the same error message pops up. It's not that there was a problem with their computer. Maybe so. Maybe so.
Harping on the sort of user aspect point, yet again, the compile time errors. So with GWT, you get to do things at compile time instead of having the users be your testing army, really. It doesn't make sense to have to pop up arcane JavaScript errors similar to the ones we just saw.
Yeah, absolutely. And with, dynamically typed language like JavaScript, the only way to be sure that you don't have spelling bugs, really spelling bugs,
typos,
is to execute every code path. And you just can't, you're not going to do that with testing. So using a static type system, you're able to kind of eliminate entire classes of bugs like that. And as Josh pointed out, you can use static analysis tools like find bugs. You can provide source to find bugs as well. And it can help you look through your GWT code and find errors. And that's really valuable. That's something that you really cannot do in general for JavaScript that you can do for Java.
And then one of the important benefits of GWT at the beginning was that you're able to use tools you're already familiar with. We know a lot of people are using JUnit. We want to make it very easy for people to hook in their testing harnesses.
Absolutely. And it's also, it's really nice to be able to reuse code instead of having to copy and paste. Because as two things, Josh said, when bugs are found in framework code, the bug's fixed, you recompile, everything's better. But also, when you're writing new code, even within your own company, if there is an incentive for you to kind of write it from scratch because it's too much trouble to go find the code that you should reuse, the odds are good that you're just going to write new bugs instead of reusing already debugged libraries. So reuse has a real, not just productivity effect, but actually quality effect at the same time.
Yeah. And then since all the development we're doing is sort of in the open and we have a lot of feedback as part of the iteration of GWT itself, we're getting a lot of improvements from the open source community. But actually, it's interesting because in some sense it broadens the scope of the QA department. Basically, there's so many different use cases being tested with GWT. We get a lot out of it.
Yeah, you got, like on the developer forum alone, there's over 10,000 developers, all of whom are looking at GWT, and if they have a problem, they can look directly at the source code, interact with the open source contributors, and work through these problems. This is so many more test cases than any single organization could actually go through. So it has a big quality effect.
And they can file issues, and we can comment about, we're going to get to that one in this release or in this release.
Absolutely.
Sort of
and they can
open
help the GWT team avoid a lot of bugs, too. I can't tell you how many times we've done code reviews, which we do all code reviews publicly, and we don't do any check-ins without a code review. So there's been so many times when we're about to commit something, and somebody will say, oh, by the way, did you know that this will invalidate this other thing? So the
There's a lot
more
of scope
eyeballs,
involved,
the better.
so more eyeballs, yeah.
Definitely. And then there's more to come, so it's an area we continue to work on. It is possible to test with Selenium now. Have you guys seen Selenium? It's a nice functional testing framework for web applications. It's possible to use it now with GWT, but we want to make it really easy and also efficient. So to the widget set, we're adding a capability called set debug ID, so that you can give an ID to any widget, and then it'll sort of automatically provide deterministic IDs for all its children. Then you can write Selenium test cases against the DOM structure by referring to those IDs. So that's a good idea. Any JavaScript framework could do that. But what GWT can do that's special is that when you compile for production, all the code that sets the debug IDs completely goes away. That's not to say you call set debug ID and it doesn't set it. The call itself to set debug ID goes away. So it's as if you had never written it in the first place.
So you get the functionality with it without the cost.
Right. And that ties back into the concept called deferred binding, which is, there's Ray Quarmall is doing a talk on that. And it basically, believe it or not, it's going to explain how you can write faster than possible code. Benchmarking is another example of how we can actually both make GWT better in terms of performance, reliable speed. And also, you can make your own applications more reliable in terms of speed. There's a benchmarking subsystem that was part of GWT 1.4.
So you're not supposed to be able to read that code, by the way.
Yeah.
So I just want to make that clear, because
yeah, that doesn't really matter. The point of that code is that it's really just it's a JUnit method, and our benchmarking subsystem works within the context of JUnit. So you write a test method, although it can be called whatever you want, and the benchmarking system will repeatedly call your test method in a variety of different ways, and you can kind of configure it. But for example, we use this to test the collections implementation. So we observe, like, okay, let's say we append a bunch to the end of an array list. What does the time curve look like on that? Or what if we prepend? Or what if we insert in random places? The fact that the benchmarking subsystem can measure these things in a sound statistical way and then produce graphs automatically that let you see the growth curve. Like, for example, you see this guy right here, a little nonlinear. That might be something we want to take a look at.
Back up a sec, the curves here, this is IE6 on Windows, IE7 on Windows, Apple WebKit on Mac, Gecko on Unix. And these are time of the operations over the size of the array. Right.
Another way to say it is curvy means bad because it's nonlinear performance, and that's not a good attribute to have in collections. You really want to make sure that your collections are very efficient as possible. We use this to find a bug in, well, a performance bug, I guess you could say, in the way that we were implementing ArrayList because of a particular way that WebKit implements arrays. If you use an index value that is greater than 1,000, it turns the array into a hash map under the covers. And so it's tricky stuff, but the benchmarking subsystem painted a picture of where it was going wrong. We looked in the WebKit source code, and there you go. We fixed that. We changed the implementation.
And then, you know, I think Josh mentioned this point a little bit, but we fixed it. You can download it, recompile, and then you get it too.
Absolutely.
But we'll talk about that more in detail. So talk now about the time to deliver. We've talked about being able to find the features that users want.
Have we talked about that? I mean, did we cover that?
Well, so
I'm kidding. Yeah. Sorry.
You're killing me, man. Sorry. Yeah, so the basic point is that to be able to find those features for those users, you just got to prototype, test, and then keep prototyping and testing. And I think Kelly's going to talk about this a lot more in his session about usability later today, I believe.
Yep.
But the point here is that just speed of being able to iterate and respond to user feedback is very important, both at prototype stage and also after being live, because you're going to learn so much more once you actually go live and have full-scale usage versus just prototype usage with the 5 users you happen to have testing with.
And really, as developers, we shouldn't be designing UIs. I mean, you might think it's a good idea for a UI, but until you do real usability testing, you really don't want to do that. So in other words, if you have to build the right features, you have to test to find the right features, you have to prototype to test. That means you have to prototype early and often, right? So the question is, how do I get to the prototype that I can test as quickly as possible? Let me tell you some things that you don't want to have to do between 0 and your first prototype. You don't want to mess around with JavaScript funkiness, the four horsemen of the undefined apocalypse. So spelling bugs I talked about, the four horsemen are null versus undefined versus false versus empty. Scott Bloom, our compiler guru, can talk about this at length. But just to give you a short synopsis of what he likes to say is, well, obviously null is double equal to undefined, but it's not triple equal to undefined. And definitely you don't want to knot that, because if you knot that, then empty string is equivalent to true, but the string false is also equivalent to false if you knot it. So, I mean, I think that's pretty clear.
Did everybody catch that?
Right.
Because Scott will tell you that like 10 times fast.
And so I have to admit that when people talk about JavaScript making you more productive, because it's a dynamically typed language, I have to kind of bite my tongue in order not to kind of mention some of these points, but I'd actually rather spend my time making Gwt better. So another thing you really don't want to have to worry about is speed. And the truth is, if you handwrite a bunch of JavaScript, making little choices throughout the code that you're writing, nobody is so familiar with all the browser performance characteristics and all the JavaScript performance characteristics that they can really write great code with every line of code that they write. The truth is, you kind of bang it out. Oh, there was that one guy, yeah. But he died.
That was the dream I told you
His brain exploded. And then, of course, you don't want to have to deal with cross-browser support. I mean, you want to be able to test it on all these browsers with different users, but you don't really have to be thinking about that in order to get the prototype done as fast as possible. And then, browsers have memory leaks. I saw from earlier that most people are Java programmers, and fewer are doing a lot of JavaScript development. Let me tell you that JavaScript leaks in a way that Java doesn't even leak. People talk about wasting memory in Java. They're not technically leaks, they're just references. Let me tell you, JavaScript straight up can leak, especially in Internet Explorer. They said they fixed it in 97, they did not. If you use the best practices, the things that people who love JavaScript are most excited about in JavaScript, like closures and cool, fancy stuff like that, you are creating memory leaks left and right. End of story. We know this because Joel Weber, the guy who designed the GWT UI library that does not leak, wrote a tool called Drip. And what Drip does is it runs other applications and just watches how much they leak. It actually hooks all the DOM calls, and you can just see, yeah, this is leaking, this is bad.
Well, but speaking of watching how much things leak, just look at your memory management in terms of how much your browser is using. I don't know what the record is, but it's got to be gigs.
It is gigs. I've used Ajax apps that over a couple of days can build up gigs of RAM. Yeah. And that is also not good for usability. But it also seriously does interfere with your ability to test, because if you're using an application that really does leak and it starts to get slower as you're testing with it, users are going to start giving you feedback like, well, this is really slow. And so if you're not sure, but then if you refresh and they use that feature first, it would be fast because it hadn't been leaking up yet. So it really sort of confuses the results of your testing. Anyway, basically really bad. But the #1 killer of time to first prototype that we are all so very guilty of, framework-itis. I worked at a company where a director said, I think we could get something done if our developers weren't constantly trying to build frameworks, because it's fun to build frameworks. But in this mode where you prototype, get user feedback, make changes, repeat, that's not the time to be building fancy abstractions. That's the time to do the least amount of work that you can to test out a design idea that you have. So here's the way that framework-itis really begins, and it is especially true for JavaScript code bases. JavaScript, being a dynamically typed language, does not and cannot have tools that help you refactor in an automated fashion. It's just not safe, because you can compute the names of fields and methods at runtime and then call them in a very dynamic way. So how could you possibly rename a method and have a tool automatically find all the sites? Because those sorts of tools, they can't actually run the code. They can only look at the source text. Computer science says there are limits to really what you can actually figure out about what a program's doing. And in a dynamically typed language, those limits prohibit you from having automated refactoring tools for JavaScript.
And if you were to try, it'd be really slow.
Yeah, if you were to try to run every code path that is possible, that would take longer than the life of the universe. So JavaScript, hopefully we have persuaded you, does make it difficult to refactor. Now, the difficulty in refactoring, you know this with every line of code that you write in JavaScript. So you start to worry, and it starts to nag at you that, you know, my product manager is probably going to try to get me to ship this prototype.
Oh yeah, we got to do this thing.
Exactly. And so I've got to answer for it, and I'm a responsible developer, so I start to worry about this not being maintainable. So I feel the need to get it right from the beginning, even though we all agree that it's most important to make it a throwaway prototype.
Premature optimization?
Yeah, you could call it premature. It's almost premature elegantization. Anyway, what I call it is frameworkitis. You want to create a framework just so you can manage to continue to build prototypes in the future. The only problem is you don't know what it is you're really trying to build. That's the point of the usability testing, as Kelly will tell you at length in the usability talk. You just don't know what it is. And so you can't necessarily build a framework that is appropriate to the UI abstractions that you actually need to deliver. So any framework that you create is very well not the framework that you really need when you're done. So it's kind of a wasted effort. In fact, I think it's worse than a wasted effort because it kind of creates an incentive for the developer to implement things in a way that work well with the framework that he's built rather than in a way that works well for the UI that has been found to be the best.
For the user.
For the user. And then, you know, as I said, Dan will make me try to ship this prototype code.
So we can do lots of prototyping around exactly figuring out what the right iteration, what the user feature should look like. And it'd be great to be able to leverage that code and actually be able to ship it, because that makes the overall time to develop and time to market faster. So that's sort of what it's not necessarily one-to-one with every line of code you write for prototyping, but there's certainly some amount of code you're able to leverage and be able to ship. Yeah.
And then, of course, you know you can't ship it exactly as it was in a prototype. But, you know, if you've written real code that users tested, then you can at least refactor it a bit and then turn it into something that's
You can hack and slash not using any functions or something crazy like that, and then go ahead and refactor it into a bunch of
Absolutely.
functions.
So turn this pile of code into something that really ships. So let me show you what that looks like in GWT and why this really will help you proceed through that cycle really fast. Let's see, are we already running here? No, it's not. Okay. So again, this is hosted mode. What we've done with hosted mode is to try to make sure that hosted mode is just, it has the like lightweight feel that JavaScript programming itself has. So what is really nice about JavaScript programming is you have a text file that's a .js file and a browser window open. You tweak something in the text file, you refresh in the browser, and you see the results immediately. We wanted to make sure we produce that same sort of environment with GWT. So
remember, hosted mode is just a browser, so we just wanted to make sure you were able to see what it was going to look like for end users.
Right. So this is the app. You saw this app. The point is, by the way, this is still running. I don't quite have enough real estate to show you both windows at once, but
It'd be even worse if you were 800 by 600.
that's true. So then I just refresh, and the code automatically, the new code gets pulled in. In this example, you know, obviously that's not such a big deal, but in something really sophisticated like, let's see, the mail sample, there's a lot of tweakiness here. You know, you kind of want to adjust things, and you can tweak the layout here, tweak the layout there. That, when you get into that tweaky phase, that can take a lot of time if you had to do like a full, long, you know, compile and everything. Hosted mode is specifically designed so that refresh is particularly fast. At startup, it's not particularly fast, but refresh is really fast. So the idea is we tell people, keep your IDE open, keep the hosted session open, and you can sort of tweak, refresh, and then every once in a while, hit compile browse to make sure you like the way it's working in the browser. In most cases, it works identically, so you don't have to tend to compile it to web mode very often.
Yeah, the basic point is, as you're doing development, don't close hosted mode. It'll be faster. You'll get your job done more quickly.
Absolutely. And so through that, you can build up an app like this, which is a nice-looking app. It's got a decent amount of functionality. And
by the way, this is all spam. It's not necessary. We just decided it'd be better just use spam as the content for the app.
Oh, this is not lining up.
Oh, what's wrong?
This is kind of, my browser window's not. They're disagreeing about how big the screen is. So yeah, let me give you a sense of how fast this actually can be. Again, this is the real site. So if you were to write this mail application, the one thing it doesn't have is not actually fetching messages from RPC, but just in terms of how fast the UI comes up so that the user sees something happen immediately.
Instead of a spinning globe.
Okay, 1, 2, 3, go. We like that kind of usability, and we've designed GWT so that you just go be productive, and we'll make sure that all the stuff you're using is really fast. And then the compiler will make sure that we optimize what you write so that it will also be really fast.
Well, users demand that kind of reliability,
Absolutely.
which is why we like it.
So that was the edit debug cycle. Again, using the IDE, you could do the same thing with IntelliJ IDEA, and let's see, NetBeans has a great GWT plugin that actually makes it even easier to use GWT. But also you can depend on this large library of library code that we have created that spans a whole lot of different stuff. Tomorrow I'm going to do a talk on a tour of the GWT libraries where I'm going to try to talk at least a little bit about everything in GWT. All the stuff is cross-browser.
True.
It avoids memory leaks. Let Joel, go to Joel's talk about how the UI is designed in GWT, and you'll see just how thoughtful that design is, which will make you realize just how thoughtful most approaches to AJAX UIs are not in comparison.
Yeah.
Absolutely.
The last point on there is that there's a lot of stuff going on in the GWT community, GWT world, that isn't being done necessarily directly by us, but you can leverage it as well. So GWT DND is a drag and drop utility that I think actually.
Fred, I don't know if Fred is here. I don't think Fred is here.
Okay. Ah,
Hey,
got a hand.
Fred. Nice.
Hi,
Everybody says great things about DND.
Yeah, for sure.
A Chronoscope, Ray Cromwell is doing the divert binding talk, has a really awesome, Ray, are you here? What is the one sentence description of Chronoscope? It is a vector graphics visualization of lots of data points, very interactive visualization, and it's reusable and it's open source. So
the point is there's hundreds of them out there.
Absolutely.
And
so yeah, this is the library stuff we were talking about. You're not supposed to be able to read any of this. You're just supposed to go, wow, that's a lot of stuff. And we have a big team working on it and the open source community working on it. So not only is it a lot of stuff already, it's growing pretty quickly. So this is another advantage of programming in Java, both on the client and the server, is you can share source code between the two. With RPC, for example, something we have a talk about later, you can actually define a class and then use it both from client-side code and server-side code and just send objects back and forth. Or validation code, where you always have to validate on the server, but it's also nice to cross-compile and run that same validation code on the client before you have to do an HTTP round trip. And then it also makes it possible to sort of refactor code from the client-side behaviors to moving it to the server side or vice versa, depending on the circumstances that you're shooting for. And then you've got the ability to reuse existing JavaScript. We wouldn't never have expected people to rewrite their applications from scratch, obviously. So it's important to make sure that GWT can integrate with other JavaScript libraries, and indeed it does using JavaScript's native interface. So just like there's J and I in traditional Java, GWT has JS and I. Scott Bloom is going to be doing a talk about how to use JS and I for interop, and it will give you a lot of insight into how GWT really works under the covers.
So I actually think it's important to call out that the widget library is actually obviously implemented in JavaScript. It has to be, right? It's the only thing the browser really understands. And so, really we're using JS and I all the time.
Right, absolutely. And some people mistakenly think the compiler is actually what kind of knows about each browser, but that's not true. The compiler just knows how to select different libraries for different targets. So if you wanted to support a new browser that we didn't, for example, you could do it yourself using JS&I. So we wanted to make sure GWT is good at interop, but also is not a walled garden. So you can interop with really any JavaScript library that you want to. If you do a search on Google Code, you'll see literally like dozens of projects that say, here's the GWT bindings for this JavaScript library. Here's the GWT bindings for that JavaScript library. We like that.
So looking at the metrics again is, you see here we have script size. So this is GWT 1.0 and then GWT 1.4. It reduced, the point here is that as we make GWT better, you get those improvements just by recompiling. recompile, throw the code back up on the server. So what we saw for 1.0 to 1.4 was 20% reduction in the size of the script that came out, which means that it's that much faster for your users that are trying to download that code to actually get it client-side.
Oh, and we figured out a way to allocate obfuscated identifiers in the compiled code in a slightly smarter way, thanks to an open source contributor. And the net result is that the code actually gzipped better, got a better compression ratio. So not only was it less code to begin with, it compressed more effectively.
Yeah, so we saw 20%. Some people saw more like 40%, but it's going to vary a little bit. But we were glad to see 20, 25% off the board.
Absolutely.
So in a different way, then, you can sort of get faster code in the sense that, like, say we refactor RPC. Look, for example, at Internet Explorer and Safari 2 from GWT 1.0, which was released a year and a half ago, to GWT 1.4, which was released just a couple months ago. Just tremendous improvements.
So I guess we're pretty much going to wrap up here.
Yeah. So we've touched on a lot of these points before. I just wanted to sort of step back and make sure we're covering, make sure everybody understands what the main points were. GWT, you can leverage the tools that are out there. You can use Eclipse, automatic cross-browser support. You can deal with IE, Firefox, and all that without having to worry about it. As Bruce showed with the internationalization example, you just write your program in such a way that it works for the API we have around internationalization. You get 400 locales for free. We showed the hosted mode debugging for fast iterations, so you can find those features that users really want. Then we have a huge open source community that's really working on making GWT better.
And to capture all this in one single equation, you benefit by investing in GWT because a new version comes out, you download it, you recompile, everything's better. In terms of productivity, you really can't have better leverage than that. You do no work, things get better. I would say that's pretty cool.
It's like infinite productivity.
And you don't have to take our word for it.
Yeah.
This is a pretty cool one from the developer forum.
Yeah, so there's just, I'll let you read it for yourselves, but you can see that there's a question asking about how much time did using GWT really save you? And actually, Ryan Dewsbury, who you'll hear from a little later, answered saying 100% faster. And then there's more comments about sort of some of the more nitty-gritty involved.
All right, well, that's pretty much it for the high-level overview of what GWT is and how it helps make you more productive and why we don't have WYSI widgets so much. We focus a lot more effort on things that actually really matter to usability. Maybe we'll do WYSI later, but we want to start with what creates good applications for real users. So with that, let's move on. If there are any questions, if we have time for a couple.
Yeah, we have about 4 minutes, Joel.
Okay.
I mean, Bruce. Mr. Geary has a question.
This can't be good.
Can you talk for a minute about internal use of GWT, what you're using it on, for what projects you're using it on, and why you're not using it on certain other projects?
Yeah, sure. So why you're not using it on certain other projects is that everybody has a job to do. Some people are more familiar with JavaScript. It's a path of least resistance for them to write things in JavaScript. We spend a lot of time sort of evangelizing GWT publicly. I think I need to go beat a few people over the head and show them some of the metrics that we have with GWT these days.
But actually, the important point is that there are products out there that Google's using that do use GWT. Google Checkout's a great example.
Yeah.
The Google-based search interface is also another example.
Google Mashup Editor is really cool.
Right.
It's like an entire IDE in the browser for building mashups using XML. It has a whole project management facility. Then AdWords interface for advertisers also uses GWT for its most complex functionality, which is regional targeting. So it's starting to pop in. At Google, you've got some of the very best AJAX programmers, and so they're already very comfortable with AJAX. For them, it's the path of least resistance until we can go in and show them the compiler output at length and beat them over the head. And maybe they'll switch over.
It's somebody wearing a Windows mobile hat.
I was wear hats of the competitors. I wear some Java hats in Microsoft event. So that's a way. As a long-time JavaScripters across different browsers and different platforms, the Google toolkits indeed absorb 90% of the developers' headaches. I have two voices for AJAX frameworks. One is it open AJAX compliance, so they could coexist with other JS files? And the second is there a facility to incrementally download class JS files as on demand as we instantiate JavaScript object?
So as the first question, OpenAjax, right now in the current version of GWT, we don't have support for the interop hub, although it's something we're tracking really closely. I was involved with a lot of the discussions about the design early on. Sure. And then regarding incremental loading, that is something it will become more clear. But one of the actually anti-patterns for JavaScript applications is to try to do too much dynamically to kind of load things, spread out loading of things across time. So that actually doesn't typically produce the best user experience. What you really want is to try to make as few HTTP requests as possible and cache things. So like the mail example, the reason that is so fast is because it did only one tiny HTTP request. The big script was one single thing that had already been downloaded. So we may add a little more dynamic loading of things, but even then it would be in relatively large sort of monolithic chunks, because that really is measurably the best way to distribute applications.
The last question. Gentleman up front here.
But it's good to know that the conference is 2.5 days?
Yeah,
3 days
absolutely.
long.
So
Yeah, there's
we got
plenty
lots
of time.
Bring all your
Save
toughest
these for
questions.
later sessions.
And actually, there's a plug for the session tonight at 8:15. I forget what room it's in exactly, but we're just going to be sort of just doing a roundtable, or actually way more informal than that, just sort of hanging out and talking about what people have
bring
done.
your toughest, most detailed questions there.
Please.
Okay, then quick question. One of the two questions that came up in the conversation with Josh was a question about whether GWT was more for traditional programmers or for the guys who are coming at it from the HTML into JavaScript standpoint. So.
How do we answer that question?
How would you answer? What did you guys make it for? Who were you marketing? Who are you marketing it towards?
Right. So I guess in a nutshell, it's for people who really want to be able to create a great user experience. I mean, it sounds like double talk, I know, but so working backwards from that, it's for whoever is willing to write the code that can create that user experience. So if some people find writing imperative Java code too distasteful, then it's really not for them. If somebody is great at HTML, but they recognize the usability value of Ajax, then I think that person would learn enough Java to use GWT effectively. So it's not really targeted to somebody with particular skill set per se, but it's somebody with a particular attitude, which is the reason I build software is to satisfy actual users. So that's how we kind of sidestep a lot of the religious debates about what's better, Ruby, Python, Lisp, you name it. We just don't care. We picked Java because a lot of people knew it. It has a static type system, and they're great tools. The rest is just details that all should center around the user experience.